Alright, I think we did it. Okay, no rush. It's good. It's good as long as it's working. Okay, bye. Okay, guys, we are ready to roll. Okay, so with your notes, let's start adding to those. Get this listed right. There we go. Okay. All right, so we're just adding to our notes. Let's think of a number line. And what kind of numbers am I labeling here? What? Integers. Okay, integers. How many integers integers, oh, that was so messy, are between 2 and 3? Okay. He said infinite. You might have another answer? None. Okay. Anybody have another answer? 4? Okay. All right, so of none, infinite, and 4, think about it. Which would be correct? None. Okay, so if I said and including 2 and 3, then I would have 2. But between 2 and 3, remember, integers are not decimals, fractions, radicals, things like that. So there are actually no integers between 2 and 3. But what would the question be if my answer was infinite? Someone said it. How many real numbers between 2 and 3? That would be infinite. So let's include that question. How many real numbers are between... I think I forgot how to write over Christmas break. Infinite. Okay, so real numbers are the fractions, the decimals, everything's included in that. That might be a little too far. There we go. Can y'all read that okay in the back? Okay. All right. This next thing makes me think of SAT questions. Did anybody sign up for the ACT Friday? No? Okay. Has anyone taken the SAT already? Okay, see if this question kind of reminds you of that. So we're just talking about orders of real numbers here. Okay, and I'm not to the question yet, so if you're thinking, I don't know what the answer is, how would I read the statement that I just wrote? A is greater than B. Okay. A is less than B. And of course, then we could put equal to with a little line under there. So that would be A is greater than or equal to B, or A is less than or equal to B. Okay, here's my question. If A is greater than B, then A minus B is blank. If A is greater than B, then A minus B is blank. Just mull it over in your brain for a second. Now, I'm not looking for a number there. I'm not looking for 4 or negative 3. I'm just looking for some generalization here. Yes, ma'am?
Greater than 0.
Greater than 0. Okay. Positive. Anything else? Okay. Do they give me different answers?
No.
Okay, the answers they gave me were different, but were the meanings different? No. If something is greater than 0, it is positive, right? Okay, so we could answer either way. We could say positive, or I could say greater than 0. And I don't really have anything to put there, but a minus b is greater than 0. Okay, so something bigger than 0 is positive. Something less than 0 is negative. Is 0 positive or negative?
Neither.
Neither. Okay, it is neutral. Is 0 even or odd or neither? 0 is considered to be even, but it's neither positive nor negative. Okay, so if this is a little confusing to you, and sometimes on SAT questions they'll give you really generalized questions like this, I would make a number line and just sort of assign some values. Give me a number A that's bigger than a number B. What could I use? Okay, so let's say I have 3 here and 5 here. So this would be A and this would be B. A is bigger than B. Then A minus B, okay, 5 minus 3 is a positive number. It's 2. So sometimes on the SAT or tests like that, if you have these real general statements and they want you to kind of looking for theory almost, number theory, then just sometimes assigning a number to that can make more sense of it. Okay, if A is less than B, then A minus B is what? Negative. How else can I say negative? Less than 0. Okay. And again, let's do a number line. If A is less than B, we can use our 3 and our 5 again. It's just this is now A and this is B. Then I can see that A minus B, 3 minus 5, will give me negative 2. Okay? All right. What about if A is greater than or equal to B? Then A minus B is what? Or what? I'm going to have to give you 2 blanks on that one. If A is greater than or equal to B, then A minus B is what or what? Okay, I could say greater than or equal to 0, or I could say positive or 0. So combining those, I could say greater than or equal to 0. Okay? All right. Okay, let's deal with some number lines again. We're going to talk about inequality notation versus graphing on a number line versus interval notation. Okay? All right, so we'll call this example 1. All right, graph the following and write in interval notation. X is less than 3. Okay, so this right here is called inequality notation. Okay, so an inequality is when you have a less than or a greater than. Now, it could be less than or equal to, greater than or equal to, but it's some comparison using one of those. So x is less than 3, inequality notation. We're going to graph it. So I wouldn't graph this with an x and y axis, right? I just have one variable. We use an x and a y axis when we have 2 variables, x and y. So I'm going to use a number line, which is really just an x-axis, right? Isn't that just an x-axis if I draw a number line? So if I want x is less than 3, I'm going to put my 0 down here. 3, 2, 1. Okay, how do I graph that on a number line? How do I show where all the numbers are less than 3? solid dot in a line, open circle.
If it goes on left.
Okay, can we agree we'll shade left? Okay, open circle or closed? Open. What does closed indicate?
Whenever it's greater than
To include the point, exactly. Okay, so to graph this, I would do open circle at 3. And shade, I'm going to do a little squiggle. Ooh, that one's dead. Shade to the left. That one's dying too. And so I can't list all the possible solutions to that, right? Because there's an infinite number of numbers that are smaller than 3. So the way that we list our answer or show our answer is by shading where all those numbers are found. Okay, there's another way to graph this without using an open circle, and that's by using parentheses and then shade left. Okay, now you would put it on the number line. I just already had the open circle, so I did it above. But the parentheses indicate go up to that number but don't include it. And I'll show you what we do if we do include it in the next example. Okay, so that would be graphing it. Okay, so we have inequality notation. We have a graph of it. Now we're going to write in interval notation. Okay, so interval notation is when you have either brackets or parentheses, but you write the smallest possible value, comma, largest possible value. Okay, and sometimes it looks like an ordered pair. It is not an ordered pair, but it's always smallest, comma, largest. Okay, so if we think about the smallest number that we shaded here, what is the smallest number that's shaded? Yeah, there's not an exact number, right? Because it keeps going to the left, so we just call that negative infinity. What is the largest number I have graphed? You can't really answer it, can you? Like, it's 2.9999999 forever, right? Because we go right up to 3, but we don't include 30. So our interval notation of this would look like this. Smallest is negative infinity. Largest is all the way up to, but not including 3. So I would do negative infinity, comma, 3 parentheses. The parentheses mean don't include the number. If we want to include the number, we do a square bracket. Okay, infinities or negative infinities are not exact numbers, so we never use bracket with those. We always use a parentheses. So that means smallest is negative infinity, go up to 3, but don't include it. So that parentheses is why sometimes you'll see a parentheses graphing it instead of an open circle. It just corresponds with that same notation. Okay, so this is our interval notation. The higher in math you go, the more we tend to use interval notation rather than inequality. Okay? All right, so the next one we can do much quicker now. What if I wanted negative 1 is less than x is less than or equal to 4? Okay, now I have a starting and a stopping point, right? That, like, this is not going to involve infinity. However, there are an infinite number of values that I'm graphing here. So if I set up my number line, I have to at least include these from negative 1 to 4, so I just put one more on either side there. Now, if we were shading, we would use an open circle at negative 1, but a closed circle at 4. Or I'll do this one with the bracket and parentheses so you can see what it would look like. So on the graph, I would need parentheses at negative 1, bracket at 4, and then shade in between. So some people prefer this to the open and closed circles because it corresponds with what I'm going to use over here with the interval notation. With the interval notation, my smallest number is negative 1, but it's not included, so I'll do parentheses, comma, my biggest number is 4, but it is included, so I'll use a closed bracket or a squared off bracket. So these notations transfer exactly the same on the graph if you're using those. Now, if you don't like those, then it would be open circle here, shade, closed circle there. So it's the same thing. You decide which one you prefer. Some textbooks that you encounter will use the brackets and parentheses. Some will use the circles. Okay, any question on that? All right, next one. X is greater than or equal to -2. Okay, I'm going to let you try your hand at this one. And then we'll discuss it. Okay, so do the shading for me on your number line, and then try your interval notation as well, and then we'll discuss it all together. Talk to your neighbor about it if you'd like. Okay, you got it? Raise your hand if you like the open circle, closed circle. Oh dear. How do I get rid of that? Okay, I don't think it's supposed to do that. Oh well, we'll ignore that. Now we'll ignore all of that.
Oh, there's maybe that eraser thing.
I tried it and it just made more squiggles. That's really weird. Okay. Never had to do that, but okay. Oh, and it's gonna remain there? That's not cool. Oh no, we gotta figure out how to get rid of that. Okay. Who likes the open circle, closed circle better? You're used to it, that's just what you prefer. Who likes the bracket parentheses? Oh, wow, okay. I'll use that then. Okay, so someone tell me what your graph looks like. Describe it to me. Anybody? All right, Baden. You can't volunteer other people. It volunteers you.
Well, shaded circle on -2.
Okay. And?
Shaded to the right.
And where do I stop? You don't. Okay, it keeps going. Okay, so if you had a bracket, yours would look like that. Okay, so someone tell me what your interval notation looks like.
Bracket.
Bracket, okay.
-2.
Okay.
And then infinity.
Comma, infinity. And infinity, negative infinity is always parentheses. Okay, any questions on those? Okay, we got to get rid of this. How are we going to get rid of this? Think we just got to start over? Change that. No. Oh, yucky.
Press try the white.
The what now?
Like, see, like the back, it looks kind of like an eraser on your pen.
I did.
Oh. You try
Like
that.
everything is marked.
Try the reset button on the far left of the bar.
Don't have confidence. No. Okay, we are not going to be stuck with this. We're going to have to start over because I can't live with that on the screen the rest of the block. Okay, is everybody all right with these? All right, let me pause it and get a fresh screen. Ah, I must have hit something without realizing it. Okay. Fun little surprises there. Okay, so next I'm going to give you a written description, and then you are going to come up with all three ways of representing this. Okay, so we will write an inequality notation. Graph and interval notation. Of the following. The real numbers between -4 and -1/2. Real numbers between -4 and -1/2. Okay, so go back up here. I want it this way, and this way. On your mark, get set, go. Talk with your neighbor, or talk to yourself. Okay, do we have all three? Q pencil's still moving. Tell me what you have as far as inequality notation. Anybody?
I have -4 is less than or equal to x is less than or equal to -1/2.
Okay. All right. So let's talk about a couple things here. This is a compound situation. Okay, so Austin broke it up into two different statements, which is perfectly fine. But then we can also crunch it into one. So when I say compound, I'm talking about something like this, right here. So x, a -1 was less than x, but x is also less than or equal to 4. So that's two different scenarios, but they fit together, and I can write them as one because the numbers that satisfy both of those conditions fall between those two numbers. So that's what we have here as well. Okay, so this is, tell me one more time what you said, Austin.
-4 is less than or equal to x.
Do I need an equal to? No. Okay, so I'll take your less than. So -4 is less than x. Okay, and what was your second one? Okay, what do we think about this? If -4 is less than x, x is greater than -4, right? Okay, so that's one way of writing it. Here's another, or who has another way of writing it? Give me one. Okay.
-4 is less than x. X is greater than -1/2. I mean less than -1/2.
Okay. Okay, so there's the other way. So anytime you have an and situation, you can smush it into one statement. These are tricky. You have to make sure X is in the middle. Make sure your arrows are pointed the same way. Your smaller numbers on the left and your larger numbers on the right. Okay, or you can stick with this. You could have also said X is greater than -4 here. If it's not an and situation, then it cannot be written this way. And that gets a little confusing. Okay, what does your graph look like? Anybody? We definitely need a -4, -3, -2, -1, 0. Someone describe your graph to me.
I put an open circle between the -1 and -0 and an open circle on the floor.
Okay.
And I shaded
In between. Perfect. So -1/2, I'm just going to estimate it's going to be right there. -4 and between would be literally shaded between. Question on that. If you were using parentheses or brackets, then these would both be parentheses. Okay, someone tell me what your interval notation is. Okay?
parentheses, -4, comma, -1/2 parentheses.
Perfect. Okay? Is everyone okay with these? All right, let's do this one next. All positive real numbers. All positive real numbers. Interval, graph, inequality. All three. See what you can come up with there. Sometimes I think it's easier to start with the graph, for me. Once you shade it, then it's, in my brain, it's easier to translate to the other two. All right, would someone like to come up and put their answers up here? Come on. You gotta just watch all these crazy chords. All right, what do we think?
Yeah.
All of it? All good. No corrections.
Wouldn't it? So,
Yes.
is it 0 a whole number? Which would be a real number?
0 is a real number. Mm-hmm.
So, would it be greater than
Exactly, yes. So because 0 is a neutral, when we talk about positive and negative, we would not include it. So that would not have an equal to with it. Open circle on the 0, shade to the right from 0 to infinity. Questions? Very nice. Let's see. What if I wanted you to do the same for all real numbers? All real numbers. Anything goes. All right. What does your graph look like? Yeah, the whole thing is shaded. It doesn't even really matter where I put my numbers because the whole thing will be shaded, both arrows, because it's going on indefinitely in both directions. Okay, so how would that look if I were writing it like this? I mean, how do you say everything with less than and greater than?
Leaving negative infinity is less than and greater than.
Okay, I could do negative infinity is less than x is less than infinity. Yeah, that's kind of awkward, isn't it? Use 0 where? Yes, you could. Sure. You could do that. And then in interval notation, I would have parentheses because we're dealing with infinity, negative infinity to positive infinity, and both would be parentheses. Okay? Questions on that? All right, one more, and then we'll talk about some exponent rules to review. All right, last one of these. I want real numbers larger than 0 or less than or equal to -2. Real numbers larger than 0 or less than or equal to -2. Start with a graph on this one. Shade your number line first and then try to write the other parts. Alright, this one I think is a little tricky. Number line might be the easiest part of this. What does your number line look like? Open or close circles? Okay, closed on -2 or a square bracket, and then on 0, open. Okay, am I shading between? No, just the opposite, right? So these are going to the right, these are going to the left. Is everybody okay with the graph? Okay, so how do I write that using inequalities? I have to have two different statements. There is no overlap in what I have shaded. This one back here where I said we could smush them together, or down here, those were shaded in between the two numbers. That's not the case here, so I have to write this as two separate statements. Okay, so dealing with the one on the left, I would say that's x is less than or equal to -2. Okay, or then we have this other part that's shaded with no connection to this, totally disconnected. X is greater than 0. So it has to be two separate statements because there is no overlap in these shaded regions. When there is overlap, then you can smush them into one statement. Okay? All right, so then the question becomes, what do I do over here with the interval notation? I again have to have two different statements. So let's just deal with the one on the left. What would that look like using interval notation? Smallest comma biggest. Go ahead, Kami. Good. Okay, so that takes care of the left. Now, there is a symbol we use for or, and that is called union. And it looks like a U without a little stem on it. Okay, so that symbol means or. So -∞ to -2, union. Then we just do this one by itself as well. So that part would be parentheses, 0, comma, infinity, parentheses. And so all of that will be your interval notation. Okay? Question? Alrighty. Okay, so let's go on and talk about some exponents for a second. If I have a negative fraction, I'm going to write 4 fractions, and I want you to tell me if any of these are the same. Which ones are equal, if any? The first 2 are equal. We'll buy that. What about this one? Yeah, let's just put a big old X through that one. That is not the same. So often, these first 2 ways are the way that we write a negative fraction. Just put it out front or put it in front of the numerator. It is not wrong to put the negative with the denominator. You just don't see it that often because sometimes that negative will get lost if it's written with the denominator. But it's not wrong. Okay, so let's just do this. All of these 3 are equal to each other. Certainly a negative divided by a negative is a positive. Okay. All right, so now let's talk about raising some negatives to exponents. You guys know this, but so many times people get this wrong because they just don't stop and think. What is the answer to that? -3 squared equals 9. 9. Everybody's good with that? Everybody? I'm not. No. -9. No, she's talking crazy now. What is the squared attached to? Just the 3. Okay. So remember those things called order of operations? Please excuse my dear Aunt Sally, like it tells us how to simplify expressions so that we all get the same answer. Okay, so exponents takes priority over this. That's basically a negative being multiplied by something. So we squared the 3 and we get 9, and then we multiply by the negative out front and we get negative 9. Now this equals what? Positive 9, because that is saying square the negative 3. So negative 3 times negative 3 is positive 9. Okay, so you guys know that, but so many times if you are subbing something in, like let's say we had negative x squared plus 3x, and I want you to sub in negative 3. And you'll go to your calculator and you'll start typing it in and you'll get the wrong answer. Because anytime you square, or let's just say raise to a power, a negative number, that needs to be thought of as in parentheses. Okay? So let's do this one mentally. What would you get if you subbed in negative 3?
0.
Okay. Anybody else?
Negative
18, 0. Anything else? Okay, well let's try it. So negative, sub in negative 3, plus 3, sub in negative 3. Okay, well here, when I square negative 3, negative times negative is a positive, but then I have a negative out front, and then that becomes negative 9, and that one would indeed be negative 18. Okay, be very careful subbing in negatives. Okay? Be very careful. Okay, take your exponent sheet that I gave you. This is a rundown of all the exponent rules. I know you have studied these, and if you had Algebra 2 recently, then you did lots of practice with these, didn't you? Okay, some are easier than others. For example, product of powers, if I multiplied 2 cubed times 2 squared, we add those exponents together and get 2 to the 5. If I have a product and then it is raised to a power, both of those quantities, or if there are more, each quantity is raised to that power. So for example, if I have 2x cubed, a lot of times people will forget to cube the 2 in addition to cubing the x. So that will give me 8x cubed. Okay, if I have a fraction and I have exponents here, then I can condense by subtracting the exponents. For example, if I have x to the 7 over x cubed, that is the same as x to the 4. If I have a fraction that is raised to a power, both numerator and denominator get raised to that power. So if I'm squaring negative 3/4, negative 3 gets squared as well as the 4, giving me 9 over 16. Power raised to another power. So for example, 2 squared cubed. Those exponents get multiplied. 2 times 3 becomes 6, which in the end I get 64 there. But if I had x squared and I raise that to the 4, then that becomes x to the 8. Why is something to the 0 equal to 1? Anything to the 0 is 1. Does that make sense? It really doesn't in my brain. It's like, what? Raise it to a 0 and you get 1 no matter what it is? Okay, you guys put your phones away, please. All right, so it's actually a pretty simple pattern. Let's look at something real quick. What if I had 2 cubed, 2 squared, 2 to the 1? Let's even start with 2 to the 4. Okay, those are simple quantities. What is 2 times 2 times 2 times 2? 16. What is 2 cubed? 8. What is 2 squared?
4.
And what is 2 to the 1? Okay. So as I'm coming down this list, the exponents are being decreased by 1. 4 minus 1, 3 minus 1, 2 minus 1. But what's happening here? What is this pattern that's going on? Okay, they're being divided by 2, being halved, right? So we're dividing by 2 every step of the way. Divided by 2, etc. Well, let's continue that pattern. Okay, so if I have 2 to the 1 and I continue this pattern of subtracting 1, then that becomes 2 to the 0. Well, let's continue the pattern. What's 2 divided by 2? 1. So it's really just a pattern that's followed. All right, well, let's continue it because then that will lead into that negative power rule that comes next. If this is 2 to the negative 1, what is 1 divided by 2? 1/2. Okay, 2 to the negative 2. What is 1/2 divided by 2? 1/4. Okay, this is also 1 over 2 to the 1. This is also 1 over 2 squared. Let's go one more step. 2 to the negative 3. What is 1/4 divided by 2? 1/8, which is 1 over 2 cubed. Okay, so that's really where that rule, anything to the 0 is 1. It's just following a pattern. And then that's where this negative exponent rule comes from, following the same pattern. So if I have 2 to the negative 1, that's 1 over 2 to the positive 1. 2 to the negative 2 is 1 over 2 to the positive 2. 2 to the negative 3 is 1 over 2 to the positive 3. So what is x to the negative 5 equal to? One over x to the 5. Okay, so that's exactly what happened here. This 2 to the 1 went to the bottom. 2 squared went to the bottom. 2 cubed went to the bottom. X to the 5 goes to the bottom. Okay, so that's actually the next rule on here. Okay, but then the same thing happens. What if I had 1 over x to the negative 5? Okay, well, let's use the same rule we talked about. Let's ignore the 1 over. And I'm going to say, oh, well, this becomes that. This becomes that. Just like I wrote up here. Okay, but 1 over x to the 5, that's just messy, isn't it? Okay, this really means 1 divided by 1 over x to the 5. When we divide by a fraction, it is the same as multiplying by the reciprocal. Okay, so this becomes 1 times the reciprocal. But 1 times x to the 5 over 1 is just x to the 5. So essentially what happens is this moves to the top and becomes positive. So you have negative exponents, move them, make the exponent positive. That's the short rule that we use. Okay? All right, so those are our negative exponents down here. And then this one is kind of confusing as well. Who has a calculator handy? Okay, take your calculator and type in 9 raised to the 1/2. 9 raised to the 1/2. I get 3. Okay, what about 16 raised to the 1/2? 4. What's happening? It's the square root of that number, right? Okay, so an exponent of 1/2 means square root of that. What about an exponent of 1/3? Cube root. Okay, this number down here that's in the denominator, this square root actually has a root of 2. It's also called the index. We don't usually write it in for square root, right? But there's an understood 2 right there that we actually never write in. But if it's any other root, we have to write it in. So this denominator is your root. So on this one, I would have to write in the 3 to indicate cube root. So 4 is 4th root, 5, 5th root, etc. Okay, but what if I had like x to the 2/3? Okay, exactly. The denominator is still the root. So this is still a cube root. But this is the numerator, which is the exponent, like that. Now, you can write it another way. I could also say the cube root of x and then square it. It's the same thing. So sometimes if there's a number there, sometimes this is an easier way to simplify something. For example, what if I had 8 to the 4/3? Okay, tell me if this is easier, cube root of 8 to the 4. I'd have to really stop and think about what 8 to the 4 is. Or is this easier, cube root of 8 and then raise it to the 4? That's much easier. Cube root of 8, I know that is 2. And then 2 to the 4, that's 16. So sometimes it's easier to put that exponent on the outside. If it's a variable, it doesn't really matter. But it can go under the root or outside the root. Question? All right, so that is just a review of our handy-dandy exponent rules. Exponent rules never, ever go away. Ever. Like, we always use these. That's why we just keep going back to them. Okay, so let's do this. Example 3, I believe this is. Simplify 2ab cubed times 5a squared b to the 5. All right, see what you can do with that. Jot down your answer on your paper. Two ab cubed times 5a squared b to the 5. Can I type this in my calculator? No. Hi, someone I haven't heard from today. Volunteer what you got. Crickets.
I'll do it.
Oh, there we go.
10a cubed b to the 8th power.
Do we agree? What did he do with the exponents? All right. Why didn't he add the 2 and 5?
Because there's parentheses.
Okay, what are these things called out here? Coefficients. They're just being multiplied. Those are, now they are a constant, like if it was a +2, then we call it a constant. So you're right. But yeah, in front of something that's being multiplied, we call it a coefficient. Okay, let's try this one. That one was way too easy. So let's try this one. All right, see what you can do with that. U squared v to the -2 over u to the -1 v cubed. A little bit harder? No, you got it?
No, that's fine.
All right, someone I haven't heard from. Tell me what you got. If it's wrong, it's no big deal. We move on and we fix it. All right.
U cubed b to the -5.
What do we think?
Correct.
It is technically correct. Okay, but if I said I want positive exponents, then how else could I write it? But there's nothing, I didn't tell you that, so this would be totally correct. But what else could I do to make that exponent positive? Move it to the bottom. Okay, so did any of you write it that way? Okay, did anybody have something totally different? I know somebody did. All right, I'm just curious, did you guys subtract exponents or did you move negative exponents first?
Subtraction.
Okay.
Subtraction.
Okay, and both answers would be correct. Personally, I would move what's negative, and then I would deal with simplifying, but it's perfectly correct to subtract them first. Okay, do I need to walk through how to get this answer? Just nod your head at me if I do. Okay. All right, last one of these. See what you can do with that, hot shots. They're not in.
Yeah, they just yeah.
It's cool tennis shoes. Anybody still working? I see pencils maybe. All right, what do I have to do first on this one? Kind of apply that exponent of negative 3. Okay, so what happens to x squared when I raise it to the negative 3? Not negative 1? We are multiplying the exponents. What happens to 2 raised to the negative 3? Okay, I'm just going to leave it like that for now. Okay, now I'm going to move the negatives and make them positive. So that means everything is switching places, right? X to the 6 will go downstairs. 2 cubed will go upstairs. And now what do you end up with? 8 over x to the 6. Any questions on that one? Be honest. Who missed that one? All right, about half and half. Okay. Any questions? Yes.
Can't you just flip the x squared divided by 2, and then that makes the 3 positive?
Yes. So you could flip the fraction first and make the 3 positive, then apply the exponent. Yep. Anybody else do that? Okay. Good. All right. One last thing. Sticking with the idea of exponents, we're going to talk just a second about scientific notation. I'm going to show you a problem, and we are going to do it in our head. We are not going to grab a calculator, and you're going to be so amazed at yourself. Okay, scientific notation is when you have a number times 10 to a power, right? But that number has to be what? I mean, you deal with this not so much in math at all. We're going to approach it just as an exponent problem. But in science, that number in front of 10 to a power has to meet certain criteria. What is it? Less than 10 and bigger than 1. Okay. So C is between 1, including 1, but less than 10. Okay. And M is an integer. So I'm not talking about, raised to the 1/2 or anything like that. Okay, so that is what scientific notation looks like. Okay, we are going to be so impressed with ourselves. As you get to know me a little bit better, I am all about some mental math. Now, not to the point of missing a problem because you won't grab a calculator, but we can often do so many things quicker in our heads without touching the calculator. Okay? And we just automatically grab for this sometimes, but sometimes if you stop and think about something mentally, we can get there faster. Okay, without a calculator. Are you ready? 360,000 times, oh dear, 4 billion, 500 million. Just trust me on this. We're going to do it mentally. And then we're going to divide by 18,000. Okay, so what I'm going to suggest is changing all of these to scientific notation. In other words, rewrite them using exponents. Okay, so if I were to write this in scientific notation, what would it look like? 3.6 times 10 to what power? 1, 2, 3, 4, 5. Okay, there's that one. Okay, let's do the same over here. That's going to be a 4.5 times 10 to what power? So our decimal would be here, so we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9 is the winner. Okay, over. This one would become what? 1.8 times 10 to the 4. Okay, I want you to look at these two numbers here, 3.6 and 1.8. What is 36 divided by 18? 2. So these become 2. What is 2 times 4.5? 9. Those become a 9. You can do it. Okay, now what? Go ahead.
I don't know, I was just confused about how you do that with the decimals.
Oh, yes, absolutely. Because mentally, if I think, okay, that's really 36 and that's 18, then yeah, that's 2. So if they have a decimal there, then that's still 2. Yeah. Ooh, I have something else cool to show you. That just reminded me. Okay, what is 10 to the 5 times 10 to the 9? Use your exponent rules. 10 to the 14. And then I still have this 10 to the 4 on the bottom. Well, what can I do with these exponents? Look at that. It's 9 times 10 to the 10. Isn't that cool? That is so cool. Yes. Wow. Okay, here is my other cool math thing. What if you wanted to find 5% of 35? Did you know that it's the same answer as 35% of 5? That messes with my head. Does it seem like it'd be the same? It doesn't, does it? But it is. Okay, so you have a calculator handy? Did you try it?
Yes.
No? Yes? How would I type this in a calculator? 5% of 35.
35 times 0.05.
Yeah, of then means multiplication in math. So this would be 0.05 times 35. Well, doesn't that make sense that this is 0.35 times 5? It's the same numbers you're multiplying. They both have 2 digits behind the decimal. Cool. Sometimes it's easier to switch it around and mentally do the math there. Okay? All right. I am going to stop there. Find your agendas. Remember I said keep them handy? We had last week's short, simple little agenda, but if you'll turn it on the back, you will see this. And here you will find your homework. Okay, some exponent rules, just some general things that we've been talking about there. Remember that the answers are found on Google Classroom. So check them as you go. There are some explanations worked out if you get stumped. And you've got when do we get out? We have 5 minutes. You can start and work on it for 5 minutes. Yes, ma'am. No, you do not write the question. Nope. And hey, guys, if it is something that you can mentally do, don't show work. Do it in your head. Okay?
Will that be extra points?
What?
Will that be extra points if we gave it all ahead?
Negative.
Would it be extra points if we showed work?
Negative. Okay, so for those of you who haven't had any, when we come in tomorrow, I will take questions on any homework problems that stumped you, and then I'll take up the homework. Okay? So questions first, then I'll take it up. All right, that's it for notes.